and it's the second class in the series, right? So in the pathway. So the first class is a semester class. It's called Intro to Computer Science, and that uses the CodeHS platform, right? So that's over here. And then following that, we have the year-long class, which is intermediate coding, where I use Python to teach programming fundamentals. And then the last capstone class is the AP Computer Science A course, right, in Java. And so we're talking about the intermediate coding class, and we're creating in Python. If you come to codecreative.us, this webpage here is codecreative.us. And if you enter that into your browser, you'll get to this page, and we're going to go ahead and click on the Pac-Man Ghosts. And so from here, under useful links, we have the daily schedule. We have our how-tos videos page. We have our course syllabus and our textbook, which we're using the recently renamed Interactive Python. It's now called Runestone. And if we go ahead and take a look at the schedule, we have what are we doing this week? It's Monday through Friday. Here are the standards that we're hitting, and we're basically just going ahead and completing this chapter in the textbook, right? Python Turtle Graphics. And so moving on from the daily schedule, we're going to go ahead and look at the syllabus. And the syllabus is here. What is the course description? Well, it's basically Intro to Computer Science, which was a semester course, stretched out and deepened, right? So we're covering more learning objectives, and we're also giving the students a chance to really stretch their legs. Let me just let you know right off the bat that the first two classes in the pathway are low stress. Here's computer science. I hope you love it. I hope I can hook you in. And when you do, you'll go ahead and take AP Computer Science because you want to be there, right? Not because you want it to look good on your college resume. And so what does that mean, low stress? It means no homework. It means no tests or quizzes. And it's project-based. Right? And so I'm continuing that over here in the Intro to Coding. And that's not to say that the standards are lower. Let me just say that in this class, the sandbox is bigger and deeper. So those people who find that they really like coding, they make incredible end-of-year projects. And these are the projects that I use to write letters of recommendations that really pop. Right? Like, oh my gosh, this child is so amazing. They created this video game that could have been sold as a full-blown game back when I was playing in the 80s, right? I mean, it's just like the students here at the high school are, if they get passionate in computer science, they're so impressive, right? And so we're going to be using Runestone Academy platform. And if you could go ahead and take a look at it, it uses the textbook, How to Think Like a Computer Scientist, which is kind of like a famous book. If you go to the bookstore and you go down to the coding aisle, you'll see How to Think Like a Computer Scientist on the bookshelf, and you'll see it in different languages, in Java, in Python, in JavaScript, right? And you open them all up, and they all have the exact same instructional text. Right? And you're thinking, okay, well, what's the difference between the only difference is the example programs are in different languages, right? And so what that should tell you is that all programming languages are essentially the same, right? They all use the same basic building blocks, which is variables, branches, and loops, and they use them in different combinations to solve more and more complex problems. And when you learn one programming language, you've basically learned them all. Right? Because they're all fundamentally the same. They just use different syntax in order to get these commands to work properly. And so we're going to be using Python, but when they learn Python, they're basically learning all the major programming languages that are out there, right? And so we go ahead and take a look. We have these chapters, right? General introduction, simple Python data, and what is cool about this online textbook is when you go ahead and take a look at it, it has little widgets in there where you can have code that you can run, and you can, like, for instance, right here, I go ahead and run it. It's like, okay, well, it prints out this code right here, and then I can go and modify it. I can change it around, and I can run it, and I can experiment, and I could figure out, oh, okay, that's what they meant when they were talking about sequences of numbers up in this paragraph. Right. So it's a more interactive textbook, and it engages the students more. Is how I feel, right? And so we go ahead and read through the textbook. we complete exercises, and we flip-flop back and forth. So we go ahead and go through the textbook, complete exercises, learn some skills, and after we've learned a bit of skills, then we go back onto the Code Creative website, and we complete a project. Right? And this is the Draw Something project. So let me go ahead and click on that guide. It's pretty straightforward and simple, but the opportunity for students to create something beautiful is there, right? So these projects over here have been drawn by the students using a turtle module in Python. And although they seem pretty, generic and straightforward, they're actually very difficult to draw. And so these are really impressive. Yeah. And so once they create a project, then we're going to go back to Runestone. Do more textbook, learn some more skills, right? After we've learned skills, okay, well, we're gonna go back onto Code Creative, and we're gonna build the next project, which is this Racing Turtles. Then go back to Runestone, then come back, project, learn some more skills, project, learn some more skills, project. And then by the time we finish the first semester, we get to about here. Okay, and we come back in the second semester, and that's when we leave Runestone behind and we start just using the tutorials that are found on the website. And so what I used to keep engagement high is Pygame. And so Pygame is a module in Python where students could build 2D video games, right? And to use Pygame, they got to first learn how to use it. And so I went ahead and created a couple of tutorials. First one is this Pong Game, right? So I go ahead and click on it. And what is Pong? It's this, this game here. We got 2 paddles and a ball that bounces around, keeping score. And so I first have them build it very simply, and then I have them use images and sound effects and enforce different rules, like, okay, first one to get to 3 wins the game, and it prints out a win screen, and then they click and it plays again. So they learn how to do all these things in Pygame, and then once we do that, then we got this density game where they learn a couple more functionalities of Pygame, and then finally this Raiden 2 is this video game that I used to love when I was in high school. It was in a donut shop at the high school that I was at, so after school I would go and play all the time, and I was really, really good at it. And so I said, okay, well, let's go ahead and build that. So then I made a couple of tutorials on how to build that, and what this one shows is how to create a video game where the world is bigger than the screen. Right? So like in Super Mario Brothers, the screen is this small little, but then Mario can run around the world, right? And so that's what this shows. And so once they get to this point, they're pretty much proficient 2D video game developers using Pygame. And so then it's build your own, right? And in build your own, they could do several different things. They can go ahead and do a Pong redux, right? Go back to Pong and make it not 2 players, make it 4 players, right? Take the walls off the top and the bottom and replace them with paddles, give power-ups, right? Make the paddles bigger, things like that. They could also go back into the density project that they built and redo it. They can go back to Raiden and actually complete it, because I don't have them complete the entire thing. I just go over the fundamentals, the basic skeleton, but I don't have them build the actual game. But some students choose to go back and do that, right? And then if they don't want to do that, then they can go ahead and build their own game. So that's the BYOG. And if I go and click on that, this is the part of my webpage that I'm most proud of, because this is where the students have been able to stretch their legs and really build things that are amazing, right? Like last year, there's this girl, Yu, and it takes a little while to load, but she built Tetris. Right? And so she rebuilt the whole thing. And it's like, I don't know, even when I sit back and think how would I rebuild Tetris? It's like, I think about it, I'm like, man, I don't know how I would do it. Right? And so she really impressed me when she did it, and she did a very good job of it. It works. Everything looks the same. Right? Over here for Minesweeper, this was Kyle. He did this last year, and he rebuilt Minesweeper using the same images, the same rules, the same everything, right? So you could choose beginning, medium, hard. If you double click on the mouse keys, then it it opens up the spaces around where you double clicked on the mouse key. Everything exactly the same. And even though Minesweeper seems like a really simple game, when he was building it and we were working on it together, because every once in a while he'd come up and be like, Mr. Lee, I'm having this problem here. It's this really complex game. It requires complex problems to be solved in order to build the game. And so it was really cool to see that Kyle actually completed it. It's perfect, right? And so he's my TA this year. He's a senior. And I'll be able to write him a letter of recommendation that just pops. And I'm going to be talking about his Minesweeper, right? And so you can come in here, and these videos, what do? They demo the game. and the students talk about the 3 biggest problems that they had to solve, and also the most prominent skills that a student would need in order to build a similar game, right? So you can come here and take a look. Jeremy rebuilt Fire and Ice, and so there's all these different games out here. Over here, Dow, he completed Raiden, right? He like actually built the first level using sprites and images and power-ups and all these different things. This guy, Dustin Lau, oh my goodness, he built Boost, which could have been packaged up and sold as like a Super Nintendo game. It's like a strategy game with these lasers and these bombs, and you got to like use the bombs to blast yourself further up so you can reach higher platforms and all these things. Amazing. So this is like the end product, right? It's like I teach the students certain base skills, and then I get them to this point. I'm like, okay, now you go ahead and stretch your legs. You go ahead and spend however much time you want to build the game that you want to build. And so it's my hope that when the students go through the class, they fall in love with computer science, right? And then they decide, hey, I want to go and study at a university level. So anyhow, that's my time. My email is dlee@smusd. It's dlee@smusd. You can go ahead and reach me there. I'm really good at getting back to you with any questions, concerns about your child or the class or what they're learning. But other than that, I think my presentation's over, and I'm going to go ahead and stop this video. I'll upload it to YouTube, and I'll email it to all you guys. So if there's anything that you missed, you can go ahead and check it out in the video. Okay? So thank you so much for joining us.
Thank you.
All right, bye. All right, stop my share. All right, bye.